not a normal explosion. It wasn't even really an explosion at all. It was the Big Bang, the leading scientific explanation for how our universe began. Hello, and welcome back to Astrobitica, your home for space news and cosmic exploration. Here we turn the mind-bending mysteries of the universe into stories that you can actually follow, stories that may challenge how you think about reality itself. Because the universe isn't just out there in the sky, it's inside you, written into every atom of your body. Before we launch, go ahead and hit that subscribe button and tap the notification bell. The cosmos are always moving, and you don't want to be left behind when we take the next leap outward. Today, we're going to attempt something bold. We're going to roll the cosmic clock all the way back, past the birth of the sun, before the galaxies swirled into being, even further back than the very first star. Back to when there were no stars, no atoms, no time as we know it. Back to the beginning. And by the very end of this journey, you'll see why this idea has reshaped not just astronomy, but our very sense of who we are and why there is something rather than nothing. Buckle up. The beginning of everything starts now. Rewinding the universe. So, what exactly is the Big Bang Theory? Imagine pressing rewind on the entire universe. Galaxies rushing backward, stars dissolving into gas, planets unforming, space itself collapsing into a smaller and smaller volume. Keep rewinding until everything, every galaxy, every particle, every quantum field is compressed into a single, unimaginably hot and dense state. We call this a singularity. And then, about 13.8 billion years ago, something extraordinary happened. The universe began to expand. But don't picture it like shrapnel flying out from an explosion. There was no center and no outside. Instead, space itself was stretching. A better picture is a balloon being inflated, every point on its surface moving away from every other point. That's our universe, not an explosion in space, but an explosion of space. The evidence? This isn't just a beautiful story. Decades of hard science back it up. First, there's the cosmic microwave background radiation, or CMB. In 1965, two radio engineers, Arno Penzias and Robert Wilson, were tuning a giant antenna in New Jersey when they heard a faint, persistent hiss. No matter where they pointed, it wouldn't go away. They thought it was interference, maybe even pigeon droppings inside the antenna. But what they had stumbled on was nothing less than the afterglow of creation itself. Light left over from when the universe was just 380,000 years old. Since then, satellites like COBE, WMAP, and Planck have mapped this radiation in exquisite detail, creating what is essentially the universe's baby picture, and it matches the Big Bang's predictions almost perfectly. Next, the abundance of light elements. According to the Big Bang, the universe's first few minutes were hot enough for nuclear fusion, producing enormous amounts of hydrogen, helium, and tiny traces of lithium. Billions of years later, when astronomers examine the oldest stars and primordial gas clouds, they find exactly those ratios. The chemistry of the cosmos is stamped within this fiery origin. And then there's the expansion itself. In the 1920s, Edwin Hubble discovered that distant galaxies are receding from us. And the farther they are, the faster they're moving away. This effect, called redshift, is precisely what we'd expect in a universe that's still expanding from a hot, dense beginning. It's as if it's a rubber sheet being stretched, carrying galaxies with us. The twist? Inflation. But the story doesn't stop there, because Almost immediately after it began, the universe underwent a bizarre growth spurt called cosmic inflation. In less than a trillionth of a trillionth of a trillionth of a second, the universe ballooned faster than the speed of light. How is that possible? Remember, it wasn't matter racing through space faster than light. It was space itself expanding. Inflation explains why the universe looks so smooth and uniform across vast distances, yet still seeded with just the right imperfections for stars and galaxies to form. Without it, the universe we know simply wouldn't make sense. Alternative ideas? Of course, science is never finished, and the Big Bang is not without challengers. The steady state theory once argued that the universe has no beginning or end, that new matter is constantly created to keep the cosmos looking the same forever. Elegant, but ultimately unsupported by the evidence. Other ideas are more exotic. The cyclic universe envisions endless expansion and collapse, an eternal cosmic heartbeat. The quantum bounce suggests our universe was born from the death of a previous one, bouncing back from collapse. These models are fascinating, and they remind us that our picture of the cosmos is always evolving. But so far, no rival explains the evidence as completely as the Big Bang. Why it matters? And so here we are, 13.8 billion years later, on a small blue planet circling an ordinary star, looking back to the very beginning. The Big Bang isn't just an abstract theory. It's the story of everything. The galaxies overhead, the atoms in your body, even the flow of time itself. It asks one of the oldest questions in human history. Why is there something instead of nothing? And it offers, at least for now, the best answers we have. But the Big Bang is only the first chapter. After the initial flash that came along, dark ages, and then the dawn. The birth of the very first stars blazing to existence and lighting up the cosmos. That's where we'll go in our next episode. If you enjoyed this journey through time, give this video a thumbs up, subscribe to Astrobitica, and share it with a fellow stargazer. There are countless more mysteries ahead. Black holes, alien worlds, cosmic webs, and together we'll explore them all. Until then, remember, keep looking up and stay curious.